Project demo by Abhishek, Apurv and Karishma. For milestone 1 build, we use Jenkins build server with 2 jobs to track 2 Git branches. The jobs get triggered via webhooks on Git push based on the branch. We set up email notifications as the post build activity for each job with custom messages. These are the 2 jobs inside Jenkins. This is the webhook inside the GitHub repository. On Git push to Maven success branch, build gets triggered in Jenkins and we send email notifications on success. Similarly, we send emails on failure and fixing of errors for branch Maven failure. For next milestone 2, test and analysis, we used a simple Java Maven project for calculator operations with JUnit tests. We measured code coverage using Cobertura, Rundoop for fuzzing and check style for analysis, both static and custom. Git hooks would reject a commit if build failed or tokens were detected. We generate Rundoop tests in Eclipse, which run in Jenkins build, and a Cobertura code coverage report is generated as shown. Here we added custom check style rules which are reported by Jenkins build. We can see that the commits are rejected on failure or the presence of security keys or tokens. For milestone 3 deployment, we used a Node.js application with Jasmine tests and PMD analysis. We configured production and canary servers automatically on different droplets using Ansible and deployed our application after a successful build by doing git push. For canary release, we used another branch named recanary. We monitored CPU and memory utilization on the canary server. We set up a global Redis store on another droplet to store feature flags and utilization of the canary server. Features could be toggled from localhost, and if the feature is set to true, we give access to set and get tokens functionality on the production server. Client request would reach proxy server, which would route every 4th request to the canary server. Proxy server would determine CPU or memory utilization on canary from the Redis store and stop routing requests to canary if they were above thresholds. This is automatic configuration and deployment via Ansible, and this is how the proxy would route requests to the production and canary server. For the special milestone, we have extended on milestone 3 and built a restart monkey and a new load balancer. We have configured multiple production hosts automatically through Ansible. Our application is deployed on each host with a restart monkey running in the background. The restart monkey checks for the CPU utilization at fixed intervals of time. Also, in each monitoring cycle, the restart monkey updates the global Redis store with CPU utilization corresponding to its host. This value is used by the proxy server to route the request to the host with least CPU utilization. During monitoring, if the threshold is breached consecutively for 3 cycles, then an email is sent to the admin notifying about the system reboot due to high CPU utilization. At the same time, the Redis store is updated such that no request is routed to this server. The restart monkey then reboots the host server and all the services are restarted automatically on reboot. Let's see the demo for the special milestone. We have set up 4 production servers, a proxy server and a global Redis store, each on different droplets. Let's connect to the Redis store. Currently, our Redis store would contain 4 entries indicating 4 running production servers along with their CPU utilization. The request from the proxy is being routed to production server 4 since that has minimum utilization. Now we would try to increase the CPU utilization of production server 4 by using stress testing. We can see in the Redis client that the CPU utilization for this server has increased. After 3 cycles, if the entry is above threshold, then the corresponding entry for the server would be removed from the Redis client. So the entry is now removed for production server 4 and the request would be routed to a different server, which in this case is production server 3. Also, we would get an email indicating that there's a high CPU utilization on production server 4. Meanwhile, the server must have rebooted. So let's go and check that. And the Redis client would again get the entry back of the production server 4. Now the request would be routed to the servers based on the minimum CPU utilization. So it's routing back to production server 4. Thank you.